All right, so today we're going to talk about how to make AI your search team. There's an interesting story that's been playing out for years now. A lot of e-commerce companies online are big enough to be, reasonably successful, but they have a pain point that they're not quite big enough to grow to the next level. They all need the same thing. They need high quality search. They need the ability to direct their users to their products. But in order to get to the next level, historically, it means hiring some very expensive expertise. Here's how it generally plays out. At level one, the kind of lowest common denominator, it's easy for most, even small teams, to crack open the search engine, index a bunch of their products, and that's usually enough to just get things going. Typically, even the smaller shops will need to make it to level two. They need to make things smarter. So they'll start, logging all of their searches, figure out which searches are the really important ones for their customers, and then they can focus on tuning the relevance for these searches and making sure that the right products show up in front of their users. Now, this is where things actually get difficult for most small and medium e-commerce shops online. If they want to go further, then that means hiring an ML team, doing like more sophisticated tracking of data, like what are the click-throughs, get some click models, prepare judgment lists, set up like hybrid search and start training models and tuning stuff to make it just work perfectly. But ever since we built this new tool that speaks back to us, there's a new option that is becoming available, and that's actually letting an AI agent serve as basically your search team. And for some cases, it might even be better than hiring a full team. So here's kind of the rationale for this. The basic experiment, which we're going to go get into in a moment, is wrapping your search inside an agent and letting the agent use that search as a tool. But the benefits are that the agents, the large language models, have been trained on everything in the public domain. So they have a lot of good common sense about things like synonyms. Are these pumps or high heels? Same thing to it. They have a good understanding about how to take a query for something like red Nike shoes and say, oh, red is a color filter, Nike is a brand filter, and it can do a lot of smart things that used to take really sophisticated algorithms and models to do on its own. So with me today is Tapasam Mandal, and we're going to talk about some of the work that we did in exploring this space.
And then I'm going to dive into the details of the experiment. So, like John mentioned, what we basically tried is having an agent wrap around a search, and then also just have like a naive, straightforward search, which is like our baseline search. It was just to tokenize the query and do a case insensitive match across name and description fields. And we conducted this on the Wayfair product dataset, which is a, I believe, pretty standardized dataset that has been used for experiments like this. And our other search that we were comparing against is basically having this wrapped around with a agent API. Here's a diagram of how this would work. So basically, the data set would go into a few shot builder. I'll explain a bit more about this in a while. This would go into the agentic search, and then there would be like the IDs that will be ranked. And then to evaluate, we used NDCG, which is normalized discounted cumulative gain, against like a labeled set of 100 queries. And then on the other hand, we have the base search, like which I explained is just a simple query, and then again we get the ranked IDs from that, put that into the NDCG, and then we get the comparison for experiment. The experiment does feel a bit artificial because we're comparing the agent against our like a very naive basic implementation of product search and not Wayfair's actual production system, which is definitely much more complicated and sophisticated. Um, but we just wanted to see if giving access to an agent at all improved anything, since that was the intention of our experiment. And each product had like three labels: exact, partial, or irrelevant. And the ideal ranking was computed across the full set of labeled products per query instead of just what it retrieved. So this also helped us understand whether the agent was actually getting the right things in the right order or not getting the right things at all. So coming to the results, we had some really interesting things that we saw the agent doing, honestly, like a lot beyond what we expected. So yeah, it did some like generally clever things. It understood that sectional and modular sofa were often the same thing. And it knew when to search broadly first and then refine. And it could reason about which fields mattered for different queries, especially if there was a longer query. There, of course, would be some words that carried more weight than the others. And we found the agent was able to just figure out which ones were more important. And then but for some queries, it did struggle to figure out which word to search for. For example, in like modern leather couch under $1,000, we found it focusing on the word leather. But the great thing is that right after it followed up with a more focused query, filtering by price range and category, and hence finding better matching results. It also did some silly mistakes, which we end up being able to solve. One of them being that if there were very constrained queries, the agent would just like start using the match operator and then coding all the phrases, so which would lead to like a very strangled search. But then at other times, it would also apply filters without knowing what filter values existed in the data set. So for example, it would like make up some hierarchy filters of like hierarchies that didn't actually exist. But as we talk about in the consideration section, both these problems were solved with better prompting. Um, and latency was interesting. It did take slightly longer than traditional search, around 3 to 8 seconds total. But this is not necessarily a bad thing because it does save the user a lot of time, either way, in terms of manually coming up with ways to search for things or at the risk of not even finding the product that they were looking for in the first place.
So, in conclusion, there's some interesting things that are on the horizon and maybe even here already for using modern AI as a simple wrapper around search. Some of the problems still at hand are going to be challenging for a little bit. It's going to be critical to give the model, the agent, a good understanding of how to use the search, how to set the filters and stuff. But because the model actually searches more like a human than an opaque model that you'd have to like fine tune on your own, then it's easier to work with. It's easier for a small to medium sized e-commerce shop to be able to debug stuff and make it better. What's more, I'll direct you to another interesting post that you can read. We'll put a link to it somewhere. But just because you have wrapped your search API inside an AI agent doesn't mean that you have to throw everything out. In this other post, we teach you how to incrementally adopt AI for e-commerce, and it's not throwing away everything and starting over. Basically, you can start with the search page just like it used to be, and slowly incorporating new elements to introduce your customer base to more sophisticated AI use and eventually land them into what I think is a really good experience of chat, where you have an assistant that is helping you think through the work that you're going about and the products that you're looking for. Anyway, so that's it for now. Thank you very much for your time, and check us out at arcturuslabs.com.